Okay, good morning. Let's continue. So, yesterday we talked about, or we started to talk about descriptive statistics. So, we said that descriptive statistics are statistics that are used to describe basically data, right? We said that there are two essential features that we would like to describe. The first is the central tendency of the data. Second is the dispersion of the data, or more precisely, right? We're talking about the central tendency and dispersion of the distribution of the data. So yesterday we mainly focused on this concept of distribution, right? We said that um, what is this? Distributions are essentially a listing of the frequency. It could be absolute frequency, it could be relative frequency, could be percentages, right? Anyway, it's a listing of all the possible frequency counts, right? Here is frequency counts, right? Of all the possible values of a variable, right? So imagine we have 7 values for a certain variable. Imagine this is a continuous scale on people's attitude toward certain issue, right? So we can count, say, amounts, a sample of 50 people. How many people scored 1, right? How many people scored 2? How many people scored, um, you know, okay. So how many people scored 1? How many people scored 2? How many people scored 3, 4, 5, right? 6, 7. Okay? So this is what we call a histogram, right? A histogram. A histogram. A histogram is essentially a graphic distribution, description of a distribution, right? Because now we have sort of we have the frequency count for the number of people, right, who scored all these different values on this variable. And this is a very intuitive figure because it tells us immediately, right? So most people score 7, followed by those who score 4, and then least amount of people scored 3. Okay. So this is for a continuous variable. We said that there's another type of graphic representation of distribution, and we call that bar charts, right? Bar charts. Okay. So again, we have frequency counts. We have, in this case, male, female, right? So we said, okay, among these, 50 people, how many are male and how many females? Okay. So here, we notice sort of a space between these two bars, whereas all these bins, right, of histograms, they touch each other. There's no space between them. And this is because we know that, histograms are used to describe continuous variables, right? Continuous variables. And bar charts are primarily used to describe discrete variables. Discrete variables. So, we use this spacing to indicate that, these two values do not overlap with each other, right? They're separate categories. Toward the end of the lecture on yesterday, we said that, now we're talking about sample distributions, right? So there are distributions based on a sample, usually a small number of people. But we said that, as we increase our sample size, right? Imagine now we have 50,000 people. So we will have more and more bins, right? And narrow bins, because more people gonna score on these values, and gradually we'll have some kind of curve, right? Instead of bins with distinctive shapes, right? So very soon, as we increase our sample size to be very large, we'll have you know distributions that look like a curve. Okay, and then we discussed three types of curves, right? So the first curve is this. Okay, imagine this is symmetrical. So we have this very symmetrical curve, right? And what this curve indicates is that there are relatively fewer cases who scored extremely high or extremely low scores, right? There's low score, there's high score. And this is basically a frequency counts, right? But most scores are clustered around the midpoint, okay? And we said that this resembles actually a well-designed, for example, examination. So very few people did poorly on the examination, and very few people excelled. But most people, right, are on the average. That makes sense. Comparatively, we also sort of introduced skewed distributions, right? Imagine this curve looks like this. We said that this is a tail, right? This is a tail. This tail is long, much longer than the tail on this side. And because this longer tail is on the right side, we said this is the right skewed distribution. So a feature of the right skewed distribution is that it's not symmetrical, right? If we impose a center line on this distribution, and if we flip this part over to this part, these two parts will not overlap, right? Obviously. The second feature is that unlike in a symmetrical distribution, right, or a bell-shaped curve, right, most values are centered around a cluster around the center. Most values actually are are clustered around toward the left side, right? While the tail is on the right side. That means there are fewer cases on this side, whereas there are way more cases on this side. So if we designate this the low score and this high score, then this distribution is most likely for a very difficult examination, where most people scored very low scores, and only a handful of people have high scores. Okay. So lastly, we talked about a third type of distribution, and this is the left skewed distribution, right? So because this time the longer tail is at the left, whereas most values are clustered to the right of this distribution. So this resembles a very easy examination, right? Where most people did very well, and only a few who did poorly, right? So as we said and as we saw, right? So, oops, what's going on? I'm sorry. What did I do? Okay. Um, as we saw, right? So distributions are indeed very common, right? They're very useful. They're not just scientific inventions, but they describe real life phenomena. Okay, so that's why they're important. Okay, let's continue. So we answered our first question, that is, what is distribution? Now we need to answer our second question, and that is, what is central tendency? And tomorrow we'll be talking about our third question, that is, what is dispersion? Okay, so let's tackle central tendency first. Central tendency is not one statistic, but a class of statistics. And this class of statistics is used to describe or indicate the most typical values in a distribution of values. Right? So, and you might ask, what do you mean by typical values in a distribution? Well, that's a very good question. It turns out that there are at least three meanings of this phrase. For value to be typical, it could mean one of the following three situations. The first type of central tendency statistic is called mode. So when we're looking at mode, being typical means being the most occurring, or a value that occurs the most often. We can also say that to be typical is the value to be expected, right? And then if we define typical in this way, then we're talking about means. And there's another name for mean is average, right? That's sort of a more common term for mean, but for various reasons, we use mean more often. Lastly, to be typical could mean that a value is at the center of the distribution. And if we define typical in this manner, we're talking about medians. So you might ask, well, wouldn't these three be the same, right? Isn't the most occurring value something that we expect? Also, isn't and the expected value always at the center of the distribution? Well, the short answer is no, right? The expected value doesn't have to be at the center of the distribution, and the expected value doesn't have to be the value that occurs most often. And obviously, the value that occurs most often does not have to be at the center of the distribution. There's one case where these three cases would overlap, would converge. That is, the most occurring value is the expected value, and the expected value is also at the center of the distribution. There's one situation where that would occur, but in many cases, these three typical values are different, and that's why we have different names for them. Okay, so let's look at these three typical values one by one. So mode is the value that occurs most frequently. That's a very straightforward definition, I hope. And let's see whether we really understand that. So in the following, I will give you a string of numbers or values, and your job is to identify the mode, given that mode is defined as such. All right, 1, 4, 3, 3, 5, 6, 7, 9. What is the mode? You might want to pause before, hearing my answer. And the answer is 3, right? Because we have two 3s. And we only have 1, 1, 1, 4, 1, 5, 1, 6, 1, 7, 1, 9. So 3 is the value that occurs most often, right? Most frequently in this string of values. So the mode is 3, right? So we say mode equals 3. Okay. 1, 4, 4, 2, 1, 3, 3, 3, 4, 9. What is the mode? Or, more precisely, what are the modes? Aha, I might say, if the question is asked that way, then we easily have two modes, because we have 3 4s and 3 3s. whereas we only have two ones, 1, 2, and 1, 9. So here we have two modes, which is entirely possible, right? 3, whoops, 3 and 4. Okay? So modes doesn't have to be a single value. There could be multiple modes for any distribution, right? So with regard, this is a sort of a sample value, right? A sample, first person scored 1, second, third scored 4, the fourth person scored 2, all the way to the last person who scored 9, right? So this is sample value, and we say, well, within each sample, or within a given sample, there could be multiple modes, as in this case. Okay? So we can easily sort of identify the mode given a histogram. So if I ask you, well, where's the mode? Given that on the x-axis we have the value of the variables, and on the y-axis we have frequency, right? The number of times that each value occurs. Very easily, you would say, mode is right here, because, value, well, I should say value, right? Mode is here because value is on the x-axis. So this is the mode because it occurs the most often. Okay? So if we only have one mode, we'll call this distribution a unimodal distribution. Uni means one, right? Mode is the adjective form of modal is the adjective form of mode. So this distribution is called a unimodal distribution. And if we have unimodal distribution, you might sort of expect that we also have multimodal distribution, right? In this case, very quickly you can identify there are two modes, right? Or these two values. These two values, right? These two values occur the most often, or more often than the remaining values, right? So in this case, we'll call it a bimodal distribution, right? Bi means two. Modal, again, the adjective form of mode. So whenever you hear people say, well, I have a bimodal distribution, then this person essentially says, there are two values in my sample that occur, equally often, and most often as well, more often than the remaining values. Okay? So mode is a very useful descriptive statistic because it can apply to all kinds of data. We said that we're have different types of data, right? We have nominal data like men, women, right? Whenever we're talking about categories, we're talking about nominal data. We have ordinal data as well. Education, right? We have bachelor's degree, master's degree. We have PhD, right? So these are categories, but these categories are ranked, right? PhD is more advanced than master's. Master's is more advanced than bachelor's, right? So it's ordinal. And then we have interval ratio data, right? So it's, basically, it's a kind of ranking with equal intervals, right? And the only difference between interval and ratio data is whether there's a true zero somewhere. Okay? All right, so as we said, mode can describe all kinds of data, right? So for example, if I say that in my sample there are 14 males and 35 females, then what's the modal sex, right? Well, female, obviously. If in this class, right, we're talking about socioeconomic class, obviously socioeconomic class is an ordinal data, is an ordinal type of data, because we not only have categories but we also rank them, right? So here we can ask, what is the modal class? Well, obviously it's lower class. We can ask, if on a 7-point scale on a certain issue, 1 indicating very oppose, 7 indicates very support, and if in this sample, 60% of the respondents chose 5, we can ask, well, what is the modal response? Well, obviously, the modal response is 5 because 60% is the majority. There can be another 60% of another response because we can't have a percentage that's larger than 100% for one given sample, right? So this is the clear majority, so the modal response is 5. Okay, that's mode. Pretty simple, huh? Very straightforward. The next type of central tendency statistic is what we call mean, right? Mean, very intuitively, is the average value in a sample. Okay, and I assume that most of us know how to compute an average value. So here I will only like to draw your attention to the restriction of computing means. That is, we can only compute means or averages for interval and ratio data. We cannot compute mean values or averages for nominal data for very obvious reasons, I would say, right? So for example, we have nominal data, male, female. Then what do you think is the average of male and female, right? That doesn't make sense. It doesn't exist. Or, we have Democrats, Republicans, and independents. So these are the values for a nominal data that we can call party affiliation. Then again, we cannot compute means for these three values, not only because they're not numbers, because we can easily assign some numbers to them, right? So we can imagine that we assign 1 to Democrats, 2 to Republicans, 3 to independents, and we'll say, well, let's compute a mean 1 times plus 2 plus 3 divided by 3. So what's that? Is 2, right? Exactly. 6 divided by 3 is 2. How say, well, the mean for people's, party affiliation is 2, and 2 here is Republicans. Wait, that doesn't make sense. I mean, how can you say that average, Democratic political affiliation is average? Why it is not independence? Right? Independence makes more sense if you average Democrats and Republicans, it give you independence. But it turns out that people, self-identify as independents, they're not holding some kind of attitudes as an average of Democrats or Republican ideals, right? They hold different ideology. So my point here is that you cannot compute mean scores for nominal data. Okay, so these are nominal data. Nominal. Can you compute mean scores for ordinal data? So ordinal data, we have lower class, middle class, and we have upper class. Okay. Again, because these are discrete values, they're non-overlapping, right? They indicate different categories of people. So again, you cannot compute averages. That doesn't make sense, right? Even though intuitively we'll say, well, isn't the average of people's socioeconomic class bit of middle class? Well, it doesn't have to be, right? Um, it doesn't work that way, right? It's not like the average of low and high, low upper is middle. It doesn't happen that way, right? So just remember that mean values cannot be computed for nominal or ordinal data. It can only be computed for interval and ratio data. Okay. All right. So to understand better how we compute means, let's have some notations. So, what's going on? So let lowercase n indicate sample size, and let xi as the ith observation or case in the sample, right? So it's very easy to imagine, right? We can have one person, the second person, the third person, da da da, the ith person till um, the 100th person. Okay. So really this I can indicate any value between 1 and 100, including 1 and 100, right? So this will give us the abstract notation for a certain observation in a sample. Okay. And then we use m as the sample mean. Um, that makes sense because, mean, that's the first letter of mean, right? The word mean. So mathematically, we express mean as this expression. First of all, we have the summation, with the sum of all values, individual values in a sample, right? So this is the summation expression. So where, this whole thing equals to the sum of all individual values, right? It looks sort of formidable and scary, but it's not, right? It's just a shorthand expression of summation, which we all know what to do, right? With this formula, and we know that to compute averages, we simply add everything up in a sample and divide the sum by the number of observations or sample size. Okay. All right. So let's see if we truly understand how to compute means. So recall we saw data on the murder rates of all 50 states in the United States. And this time, if you have individual values for each of 50 states, it's very easy to compute an average murder rate for the 50 states, right? Just add up all 50 scores, divide the sum by 50, you will have the average. But sometimes you don't have information like that. Sometimes you're given information in this way, right? You're told that, southern states, which there are 16, have an average murder rate of 10.47, whereas the northern states, there are 34 of them, right? And they have an average murder rate of 5.87. Okay, and now you're asked to find the average murder rate across all 50 states, right? So 16 plus 34, that gives you 50. So how do we find this mean murder rate? I'll give you 2 seconds to think about it, and I will discuss the answer. So if you want to solve this problem for yourself, you might want to pause here before hearing my explanation. Okay, so you think, well, this is easy. We have 2 values. That's sort of like the x's here, right? So we have the first x is 10.47 plus, okay. So we have x1 as 10.47, the second x as 5.87, right? And then we have n here, very easy. The total is across all 50 states, right? 50. And then, okay, we just need to compute these values. And let me find my calculator so that we can do this together. So you would say the sum of 10.47 and 5.87 is exactly 16, 34. And 1634 divided by 50 is 0.3268. So the average murder rates across all 50 states is this. Or you say, Andrew, that doesn't look right. Because we don't really have 50 score here. We only have 2, right? This is the first x, this is the second x. So we shouldn't divide the sum, which is 16.34, by 50. We should divide it by 2. And that will give us 16.34 divided by 2. That will give us 8.17. That looks better than 3268, right? It looks about right. It's a bit lower than southern states. It's a little bit higher than northern rates. That makes sense. Mean or average is at the middle, right? Okay, if you use the first method and obtain this number, obviously you got it wrong. And if you use the second method and got this number, you also got it wrong. Okay? So the correct answer to this question, or to obtain the correct answer to this question, we need to understand a specific type of mean. And this type of mean is called weighted mean. Okay? So this is the mean of subgroups. So southern states, northern states, there are 2 subgroups, right, that have unequal sample sizes. See, the sample sizes here are unequal. 16 obviously is not equal to 34, right? So, and then, each subgroup has a mean of itself, right? So the mean for this subgroup, the southern states, is 10.47, and the mean for the subgroup of northern states is 5.87, and they have different sample sizes. So to compute a mean of these 2 subgroups, we need to understand how to compute weighted mean. So weighted mean will be computed by using this formula. It looks quite a handful, but it's actually very simple and very easy. Where N1 and N2, let's look at denominator, right? N1 and N2 are the sample sizes of the 2 subgroups. To use our previous example, it will be 16 and 34, right? So the denominator should be 50 in our previous example, because we're asked to compute the average murder rates across 50 states. So it should be 50, right? That sounds right. Okay, then what about the numerator? The numerator, first of all, M1 and M2 are the means of the 2 subgroups. Okay, so what are they in our previous example? 10.47, 5.87, right? So it will be 10.47, what is it? 5.87. 87. Okay. And now we know what N1 and N2 is, right? So essentially, N1 times M1 will give us the sum or the total value for this is southern group, southern states. And N2 multiplied by M2 will give us the sum or the total murder rates, or the grand murder rates for northern states. So the grand total for southern states and grand total for northern states, when these two grand totals summed, that will effectively give us the grand total murder rates for the entire country, right? So that will give us the grand total, murder rates of the entire country, right? Grand total for southern states, grand total for northern states. We sum them together. That's the grand total for the entire country. And the entire country has 50 states. So we use the grand total for the entire country divided by 50 states. That will give us the average murder rates across 50 states. That makes sense, right? Okay, so now let's do this computation together. So we have, in other words, right, so 16 times 10.47, and then we will sum it with, what is it, 34 times 5.87 divided by 50. Okay, so what is that gonna give us? Let's do this. So it will be 10.47 times 16 plus 34 times 5.87. Okay, so if my calculator is right, the grand total is gonna be 367.1 divided by 50. That will give us 7.34. I believe that's the correct answer. So this value obviously, 7.34 is obviously different from the mean that we calculated using the wrong formula, right? 8 point something, right? 8 point something, right? And we notice that, the average that we used, that we calculated using this formula, right? 10.47 plus 5.87 divided by 2, that will give us 8 point something. So if we compare these two, right, the wrong mean and the correct mean, you will notice that this wrong mean is slightly larger than the correct mean, and larger in the direction that favors the southern states, the murder rates of the southern states. And that makes sense because southern rates, they have fewer cases, right? 16 compared to 34 northern states. At the same time, they have larger values, larger means than the average murder rate for northern states. So a small sample size with a large mean, that will create a bias, right? So the average that is computed using this kind of formula will be biased towards the subgroup that has fewer cases and larger means, right? So that, as we see, right? So the average computed this way is indeed biased toward the average murder rates of southern states compared to this one. So this one is more correct. It is correct because we now sort of account for the differences in the sample size across the two subgroups, right? In a sense, we correct for the unequal sample sizes of the two subgroups. So this average is more correct, right? Okay, so see if we really understand this. I have a second example for you. So let's say, we have, on a 7-point scale, right, from 1 to 7, and then 50 people chose 3, and 30 people chose 6. My question is, what is the mean response for these 80 people? What do we do? What is the mean response for these 80 people? Okay, so obviously, this question is still on this slide, so you should sort of think that maybe this formula should be used again, right? So if you want to solve this problem by yourself, you should now pause before, you hear my explanation, okay? All right, so assume that you have sort of tried to solve this problem by yourself. Let's try to solve this together to see if you get it right. So first of all, if 50 people, all these 50 people chose 3, that simply means the average of these 50 people is 3, right? The grand total for these 50 people is 3 times 50. There are 50 of them. 50 cancel, these two 50s are canceled out by each other, so the average 3. Similarly, the average response for this subgroup of people will be 6. Okay, 6 times 30. That's the grand total for this subgroup. We have 30 people, so these two 30s are canceled out. So now we have M1 is 3, M2 is 6. N1 we have 50, N2 we have 30. That's easy, right? So now we have M1 50, M1 that's 3, N2 we have 30, and M2 we have 6. We have a total of 80 people, right? 50 times, plus 30, that's 80. What is that? So 150, 180, so that's 330, right? Divided by 80. So that's 4 point something. Okay. Yeah, 4.125. 4.125. So if you got this number, congratulations. If you did not, you should check your answer. Why, right? Okay, shouldn't be too difficult. Okay, so this is our second type of, central tendency statistic. The last central tendency statistic is median. So median is the value, as we defined before, that fall right at the center of an ordered sample, right? So this is very important, and that's why I italicize this word here. So ordered sample, what does it mean? It means, well, first of all, later on we'll see what it means. So if the median is right at the center or middle of a sample, then what it will do is it will divide the sample into exactly 2 halves, right? So we have sample of values, and median is always here, right? This is the median. So we have 2 halves, exactly. So this is 50%, this is another 50%. So whenever, you heard the median income is, 72,000 US dollars, right? Then you should immediately know that in this sample, there will be exactly half of the sample of people that earn more than $72,000 per month or per year, and there's exactly 50% of the sample that earn less than $72,000 per year. So that's the meaning of median, okay? And that's what we mean when we say that, median sort of split the sample into 2 halves, 2 equal halves. So it turns out that there are steps to follow, as we do have for means and mode, to find medians. Well, first of all, we should sort the values in a certain order. It can be ascending, it can be descending, doesn't matter, as long as it's one of the two. Okay? The second step is that if the number of the values is an odd number, then median will be the value that is right at the middle of this ordered sample. Okay, let me repeat. Two steps to find median. The first step is always to sort values into a certain order. Ascending, descending, doesn't matter. One of them. The second step is to determine whether the number of values in the sample is an odd number or an even number. If the number is odd, then the median will be the value that's right at the middle of this ordered sample. So let's see what it means. So I would say, okay, find the median of the following values. 24158. Because the median is 1 because it is the value that divide these two sample into half. So two values in each half, then 1 must be the median. Well, wrong. Okay, 1 is not a median. Because if you do this, you ignore the very important first step, and that is to sort values into a certain order. Okay? So if we sort this 5 values in ascending order, it will be 1, 2, 4, 5, 8. Second step is to count or to determine, what is whether the number of values in this sample is odd or even. So we have 1, 2, 3, 4, 5. 5 is odd, right? Then the median will be the value that is right at the middle of the sample. So it'll be 4. Okay, so the correct answer. Sorry about that. The correct answer is 4. Okay, that's the median. Okay, so we just discussed the case in which, the number of values in a sample is odd. But what if, you might ask, the number of values in the sample is an even number? So if the number of values in the sample, in the ordered sample, is an even number, then a median will equal the mean, the average of the two values at the middle. Okay, so here's an example. We have the sample value 241586. Well, first of all, we need to sort these values into a certain order. So again, we do it, in ascending order, so it will become 1, 2, 4, 5, 6, 8. Okay, and now we'll count how many values are there in the sample. So it's 6 values, right? 2, 4, 6, 6 values. 6 is an even number. So we need to find the two values that's at the middle or the center of the sample. So it's not just 4, not just 5, but both 4 and 5. And step 3 will be find the mean of these two values. So the median will be 4.5 because the mean of 4 and 5 is exactly 4.5, right? So 4 adds to 5 divided by 2 is 9 divided by 2, exactly 4.5. Okay, so this is the correct answer. All right. Okay, it sounds very simple. It is very simple, but just to make sure that we understand this correctly by looking at a next example. Okay, the next example, the question is, what is the median education level? Because median is a very interesting statistic. So we said that mode Mode is our first central tendency statistic, and mode can be used to describe uh, nominal data, ordinal data, interval data, and ratio data. Okay, so it can be used to describe all these four types of data. And if you forget already, you should check back to an earlier slide on this topic. Mean, our second type of central tendency statistic, can only be used to describe interval and ratio data. Okay, it cannot be used to describe nominal or ordinal. So median, it can be used to describe ordinal, interval, right, and ratio. So mode can be used to describe all four types of data, median only three types, and mean only two types. Okay, so we just saw in the previous slide, we saw how we can find the median for interval continuous variables, right? Numbers as values. But now, how do we find the interval or the median for ordinal variables? So education level is obviously an ordinal variable. It sorts people into categories, right? But at the same time, it also ranks other categories. So obviously, the highest education level is doctoral, followed by master's, bachelor's, associates, some college, high school only, and not a high school graduate. Okay? So least educated, most educated. All right, so, in other words, so these 1, 2, 3, 4, 5, 6, 7, right? These 7 values or these 7 categories are the 7 values for this variable education level. And here I give you the frequency count for each of these 7 values. That is, in a sample of I don't know how many, right? You can easily calculate if you sum all these number up, right? If you sum this up, it's out of certain. Okay, well let's calculate the total sample size because we're going to use that. So what is the total sample size here? Should be very easy to calculate. So we have 38 plus 65 plus 33 plus 7 plus 22 plus 7 plus 3. We have exactly 175 people. All right, so these numbers mean, out of 175 people, 38 of them did not have did not have a high school graduation diploma. 65 of them had only a high school degree, and only 3 have doctoral degrees. Okay? So, my question is, what is the median education level? You would say, well, looking at these numbers, first step is to sort these values into an ascending order. So you'll be 3, right? 7, 7, 22, 33, 38, 65. 1, 2, 3, 4, 5, 6, 7. Fantastic. we have an odd number of values, so the mid value should be 22. Isn't this the median? Because we have 7 values, right? This is the value right in the middle, and this is an ordered sample, so this is our median and bachelor's degree. Answer is wrong. Okay, so here we should, be very, very careful. If you do it this way, right? If you do it this way, you're essentially dividing the values of a variable into two halves, right? You're finding the category that, because 22 correlates to the bachelor's degree, right? So you're finding a value that divides the values into two halves, whereas the median is the value that divides the sample into two halves. That's a very critical difference. Okay, so we can imagine again, right? We have a 7-point interval. 1, 2, 3, 4, 5, 6, 7. And then we can imagine there are 500 people answering this scale. So if you do it this way, you're effectively saying that the median for these 7 values is 4. Well, 4 obviously did not divide these 500 people into two halves, right? This is the wrong median, right? So here what we need to do to find a median value is like this, right? First of all, we sum up all the values to find the sample size. So we have 175 people. And we just said median is the value that divided the sample into two halves. So we're going to ask, okay, what is the half value for 175? So 175 divided by 2. What is that? It is 7.5. Okay? So in other words, we should find the value that includes the 87.5th individual, and that category will be our median education level, because that particular level will include the person that divide the sample of 175 into two halves. I'll say it again. Median. Median is the value that divides the sample into two halves. So that's why we divide this number by 2. Right? We want to find a half value for 175, and turns out 175 divided by 2 is 87.5. So that means if we have, imagine this, if we give a number to each participant and arrange them from the first participant to the last participant, right? The first, the last. And accordingly then, we would, by, placing all these participants on this continuum, right, we can very intuitively determine that about here, will be the center of the sample. Okay? So we're asking, okay, so then what is the value here? Is because we have 175 people. So the central value for the sample will be 87.5. And then corresponding to all these participants, we have, their education level. Right? All these people belong to a certain category, and these guys belong to the second category of education level. And we want to find what is the category, what is the level of education that includes this particular value that divides the whole sample into two halves. then this particular education level will be our median education level. Okay, so how to find that? So now we have a goal. We need to find the category that obtains or includes this 87.5 individual. Could this category include this person? Obviously not, because 38 is smaller than 87.5. Could this category include the 87.5 individual? Yes, it could, because 38 plus 65, that's 103. 103 obviously include this individual. So in other words, right here, from the first person to the 38th person, we have not a graduate, not a high school graduate. But then from the 39th individual to, right, yeah, exactly. From the 39th individual to the 103rd individual, right? So here's 39 to all these people, right? There are 65 of them, right? There's 65 of them here, 38 of them here, right? 65 of them here. So now this category, high school only, includes this person, which divides the whole sample into two halves. So that's why our median education level is high school only. Okay, so that's how you find the median for an ordinal type of data. Okay, so right, the important hint is median separates the sample, not values, into two halves. So the procedure is, or the rule of thumb is, the median for ordinal data is the category that contains the individual that is exactly at the midpoint of the sample. So first step is find the sample size, 175. We want to divide sample size by half because we want to find the individual that's exactly at the center or midpoint of the sample. And then we see into what category does this person, right, and divided by 2th person fall. And that category is the median category. Okay? So in this case, the median education level is high school only because 175 divided by 2, we said that is 87.5. 87.5 obviously fall beyond the 38 people. But then the next 65 people should contain this guy, right? The first 38. Next, we have 65 of them, and this will give us a total of 103. So the 87.5 individual will be about here. And this is the midpoint of the entire sample. So that's why the corresponding education level will be our median education level. Okay? All right, so this is our class on central tendency statistics. And tomorrow we'll be talking about dispersion. Okay? And very soon, and this week actually, well, this Thursday, we will have our second Q&A, and this Friday we will have our second examination. Okay? So let me know if you have any questions. See you tomorrow.